Today we have a new project. In this case is the digital design of a car. We are going to be using a distance sensor, 2 DC motors, Arduino Uno, and a breadboard. So this is a digital design in Tinkercad. So the first thing is having a new workspace in the section of circuits, and at the top left we are going to change the name to our digital design. This case is going to be DC motors distance sensor car. We are going to use 2 DC motors. So let's bring the components to our workspace. The first thing is going to be our Arduino. So we are bringing our microcontroller to the center of the workspace. The second one is our breadboard. We are going to use a small breadboard. This fits perfect in the chassis of our car. Alright, next thing is our distance sensor. We are going to use the 4-pin distance sensor. We need a trigger echo, so we need this 4-pin sensor. Alright, next our 2 DC motors. I'm going to use these DC motors because these we can see the rotation of the wheel, so I will use the gear as the wheel, and later I'm going to add the gear motors that actually are the ones who come in the car. All right, so we have here, for controlling the motors, there is a driver. So we are going to use the L293D driver there. So we have our components ready for placing them on the breadboard. These components will use 5 volts and ground. So we are going to place our mouse here, click, and draw a cable to the red rail, so that way we have 5 volts in every pin of our positive side of the breadboard. So in here we change this one to red to identify the voltage, and also for the negative or the cathode we need ground. So next to 5 volts there's the GND for ground. Let's draw a cable to the blue red. Then we're going to start placing the components next to our breadboard. The first thing are the DC motors. So we're going to place one at the left, one at the right, and then our next component is the driver. In here, since we need a little bit of space for our distance sensor, let's place this driver in the columns. We are going to use columns F and E to place the pins, and for the rows, which are the numbers, from 17 to 24. So that way we have our driver a little bit to the right. Then we can bring our distance sensor, and this one we are going to look for connections column B from 1 to 4. So let's bring our distance sensor and let's place it on B, column B, row 1, 2, 3, and 4. We can move a little bit our DC motor, so we will have space to work. So as soon as we finish the arrangement of these components, the next thing is working on the wiring of our driver. This driver needs 4 5-volt connections. So the first thing is looking for pin number 1, which is power. This is gonna be a wire going to 5 volts. Change this We can even modify this a little bit to move a little to the right. And the second one is the enable 1 and 2, which is another connection to our 5 volts. So we are going to do the same, drawing another cable. If we click twice on the cable, we actually can bend and modify the cable like this. All right, now let's look for the last pins, row 24. Enable 3 and 4 is going to be another connection to our 5 volts. So we are going to draw another cable, and here power 2, the last connection to 5 volts. If we click twice, let's redesign our cable so that way we have our connections ready. Our next one is input number 4. Input number 4 is the first connection to our microcontroller. So this one is the number 4 in our digital side of our microcontroller. So from here we are going to move a cable to the number 4. And let's change this color. I will pick brown. And that way we can identify the connections to our microcontroller. So in here we just bend as many times as possible so we can redesign the cables. That way they are not going to interfere with our wiring. Even we can move this a little bit to the bottom so we will have space in here for the next connections. So then we have a input 4 ready. The next ones are gonna be output. This is a connection to our motor. Let's pick the left motor here. So we are going to place this one on the ground. So we are going to look for the black section of our left motor and connect. We can change this one to yellow just to identify the connection of this left motor. What we are going to do next is basically changing the design of the wires so they are not going to interfere with the rest of the digital design. After this connection in output number 4, the next one are going to be ground and ground. These two connections go to the blue rail or negative side of our breadboard. So let's draw two cables that are going to be changed to blue. Connecting first our two grounds. After that, we will continue with the next pin, which is another motor, output number 3. So this one is gonna be another connection to our ground, and in this case we're going to look for the right motor and the negative side or the black connection, which is this. So we are going to change this one to yellow to identify that yellow are the motors. Then let's redesign our connections here. So we have our first negative connections ready. So after output number 3, the last cable of this section is another connection to our microcontroller. So we are going to look for the number 5, which is a PWM connection. So PWM connections, they have a line or a tilde next to the number, and the function of these pins are working or handling lots of numbers. So in this case, it's gonna be distances and the speed of motors. So we are going to move this one to number 5. And we can change this to orange to identify the connections from our driver to the microcontroller. Be designing the diagram. Even we can move this a little bit, and separating the cables a little bit. All right, so that way we have our first set connected. Now we are going back to the second part of the driver. After our enable of positive 1 and 2, the next thing is going to be our input. So this input, we are going to look for the number 7 in our microcontroller, and let's bring the cable to the digital side of our microcontroller. So let's redesign all this wiring so it's not going to interfere with the rest of our project. We continue working with the next connection. This one is gonna be our output number 1, and this connection is a motor, so we need to look for the red or positive connection of our motor, and change this to yellow. So we can identify this connection. After that, we have the 2 grounds. We have another set of negative or cathodes. So let's draw a cable to the blue rail in our breadboard. Here. So we have grounds. Next is the output number 2 and last one for our motor. So this goes to the right motor, to the red section or the anode. So from here, we are bringing a cable to our red connection. And then we have our last one. This one is an input that is going to look for another PWM connection, number with a tilde next to. So input number 2 is going to be connected to number 6. So this one goes to number 6, and let's change this to green. to identify the connection to our breadboard, microcontroller, sorry, there. So we have a little bit of bending just to identify this connection. Like that. Let's move one space. So that way we have our first step, which is the connection of a driver with motors. The last one is our distance sensor. This one has as well 5 volts and ground. So what we are going to do, looking for power or VCC, and from here let's draw a cable from A number 1 to the red rail. And we have our first cable. Our second one, trigger. Trigger basically works with a distance or sound, the back and forth of sound. So trigger is our connection to our Arduino microcontroller, and we are going to look for the number 12. So this one goes to the number 12. So looking for bending. So we do this. So we have our trigger ready. Another connection for the distance is echo. This one goes as well to Arduino Uno, and this is a connection to number 11. So we are going to find another connection to 11. Let's change this to green. Our last cable is our ground. So we are going to look for the blue rail in our breadboard and connect. So that way we have our wiring ready. This digital design Tinkercad allows us to do the simulation. So the next thing is typing the code on the section code, and in this case we are going to use text. So we open and looking for text, since we use C++ language for programming our engineering prototypes. So we are going to use this section of text. Tinkercad is giving us a sample code, so we are going to erase it because we are going to type our own. Also, if we want to see our project, there is another option that we have at the top left, this circle, which is sum to fit. If we click on it, we can resize our digital design. So the first thing is gonna be typing the variables. This type of code is divided in 3 sections. The first one is a declaration of variables. Then the next one is the function void setup. and the third one is void loop. So the first one is declaration of variables. In lowercase, we are going to type const int. This one is a data type that actually is going to read whole numbers, and basically are the connections or the pins between the sensor components and microcontroller. So in this case, we are going to look for the first pin, which is the trigger in our section of distance. So trigger, we are going to give a name to that pin, trig can be, and then equals to the connection that we use in our microcontroller, that in this case was number 12. Every time we type a line of code, we write or type a semicolon. The next thing is another const integer for the next pin, which is the echo. Echo in this case was a connection to number 11, so we give a name, echo 11. Then we will continue with the motors. Motors are gonna be the same, const int. So let's leave a name here, left ahead. I mean, these names can be changed. Left ahead is gonna be my number 7. So if I look for my number 7, is one of my inputs for controlling the motor. Then another const int for left back. This one is gonna be number 6. Semicolon, semicolon. Another const int for 5 and 4, other connections between motors, driver, and microcontroller. For right ahead, this one is gonna be our number 5. And the last const int for right back. This one is 4. Semicolons, and also checking that our division of our two words, for example, right and back, they have to be divided by a capital letter. This type of language actually does not accept spaces, so we need to use capital letters to divide. In this case, if we go to line number 5, this lowercase a has to be changed to capital. So that way we finish our first section of declaration of variables. The next thing is gonna be our void setup. So the last thing is checking our code. Inside the declaration of variables, we have other two variables on line 8 and 9 for working with the distance sensor. One is the duration and another one is the distance. We have to start in both variables with 0. So those variables are gonna be used in our section of void loop, duration and distance. And those are for formulas that we use in physics for calculating speed of sound. So that is the reason we are adding those variables. Then the section of void loop explains the function of our project. Then we use conditional statements for indicating if the distance is greater than 30, the car can continue in a straight line. In case that the obstacle is too close, so the car will stop. this project can be modified, the code can be modified. This is just a sample. And the last thing is just running the simulation, start simulation, and then opening the serial monitor at the bottom to see the condition of our car. Distance is going to be 147 centimeters. So what we need to do here is clicking on the distance sensor, and we will see the dot here, and this is the dot that we are going to actually move and modifies the distance. So our car is at 77 centimeters, so this the car will continue moving, no problem. But if we move at a distance of less than 30 centimeters, the car will stop. So in here, we can stop the simulation and closing our serial monitor, closing our code. And these are, as I mentioned at the beginning of the video, are just examples that I'm using for explaining the motion of the wheel. In the original car, the motors are actually the yellow ones, these ones. So just to mention, these are the ones that we are going to be using. And you can see here the same, the positive and the negative, those are the connections. So in our YouTube channel, we have another video that explains how to assemble the digital design or the engineering prototype in the chassis.